So dear students, today we are going to have the knowledge of the experiment which is known as Hall effect experiment. So with the help of the Hall effect we can do many things. First thing which we can do is that we can know about the charge carriers in a semiconductor. We can also know about the concentration of the charge carriers with the help of the Hall effect. So first of all, what is the meaning of the Hall effect that we have to understand? So if the general definition of the Hall effect is well known and most of the students they are familiar with it on even at the class plus 2 or after. So what is the definition of the Hall effect? Whenever a current carrying specimen is placed in the magnetic field, then a Hall electric field is developed perpendicular to both the applied magnetic field and current in this case. So here what we have, we would like to have a thorough understanding of the experiment which is the Hall effect experiment. So let me introduce the various type of the instruments which are related to the Hall effect. So first of all, if you look into the first thing, we have this the electromagnet, and this electromagnetic is these two pieces of the electromagnet, they are separated with some distance, and that distance has to be kept according to the calculations so that it does not touch the probe in this case. So the first instrument is this piece of the electromagnet. So we increase the current passing through the electromagnet, and the magnetic field which is generated inside the gap, that will increase in this case. Okay, so I will show you that how this increases. Second thing which I would like to highlight is this one. Okay, so we have, let me bring it close to this one. So this is the Hall probe. With the help of this, what we can do, that when we put it in the piece in the gap of the electromagnetic these pieces, in that case what will happen, it can sense that what is the value of the magnetic field. So with the help of this, what we can do, this cable is connected to the digital Gauss meter, and we can read out the value on this digital Gauss meter. So let me have a close look again at this. So this is okay. So we have this we can have a look at this digital Gauss meter, and here with this switch we would increase the value of the applied current to the pieces of the electromagnet. So there is a solenoid coil which is bound on these pieces. So when you are increasing the value of the magnetic the current, then in that case the magnetic field that will increase in this case. Okay, so let me show you how it does. Before showing that, I would like to introduce all of the setup in this case. So here you have, this is the switch to switch it on, and this is the switch to vary the value of the current in this case. And then this the top setup is the digital Gauss meter. So what we will do, that we would try to have this 0, and we will put this probe away from the pieces of the electromagnet. And I would also advise you not to bring this closer to any of the magnetic object or any of the objects which are being attracted towards the piece of the magnet, so that it can give you the proper value. So what you will do initially, you would adjust 0, so that you are calibrating this probe that there is no magnetic field associated when it is away from the pieces of the electromagnet. Okay, so that is done. And if you want to, with this toggle switch, you have this 1 and 10. So if the value goes out of scale, then you will flip it to this value. Okay, so that this is all about this setup, and nothing to worry at. Only one point we have to understand that is very clear. With the help of, we would like to put this into the pieces of the electromagnet here, the probe, and then we will sense that what is the value of the magnetic field. Okay. Now let's come to the next one, which is this setup, which is written as the Hall effect setup in this case. Okay. Here what we have, we are going to use part of the setup in the first semester because we do not have all the things which are there in this semester. So we are not going to have the heating part of the Hall effect, which is a different experiment of the this magnetostriction. Okay, so that is a separate setup. So we are only interested to know that for corresponding value of the current, what would be the value of the Hall voltage induced in this case. Okay, when we place the current carrying specimen in the magnetic field. Okay, so that's the thing which we have to understand from here. Okay, and then if you look at the value, so here we have this current carrying specimen. Okay, I would like to point a little bit towards this. So this is the semiconductor material for which we are interested to know about the Hall coefficient or Hall voltage in this case. Okay. So you know that, okay, when we are placing it in the pieces of the electromagnet and passing current through this semiconductor material, then there will be Hall voltage which is produced during this process, and we would like to measure that Hall voltage in this process. So I hope that there is nothing like rocket science in this experiment. Only main object is that how to generate the magnetic field in the pieces of the electromagnet. And the second question is that when we place the current carrying specimen in the magnetic field, then what will be the value of the electric field which is induced during this process in this case. Okay, so that is only aim which we have. Rest of the thing is like simple calculation by which we can calculate the Hall coefficient. So we can also know the value of the Hall coefficient. For example, if it is positive or negative, depending on that, we can predict that which type of the carriers are there. Is it the p-type material or n-type material in this case. Okay, so let's have a quick look. Now I would like to switch on the instrument and to know about the details of this instrument in this case. So how does it works? Okay, so let me have a quick look at this. Here I would like to switch on this instrument. Okay. So here I have switched on this instrument, which is the power supply for the electromagnet. And then I would also like to switch on this, let me make it 0 first of all, and this instrument which I would like to switch it on. Okay. So here what we are trying to do here, let's have a look at it. I would like to place this probe in the pieces of the electromagnet. So let me open it up, and then we would like to have a look at it. Okay. So let's see that. Okay. Here we would like to make it 0. First of all, let me switch it on, and then this on the digital Gauss meter, we need to have the value which is 0 value in this case. Okay. So let me check that why it is not working. Okay, I have connection from there. Okay, I have switched it on right now. So right now it is on. Okay. So now, if you look at this, what I would advise that this, even the wooden stand, so excuse me for this, that I'm using this metallic stand. In principle, we should use a wooden stand so that there is no this magnetic interference in the value of the magnetic field in this case. So now you see that, okay, if I go near the this, then you will see that there is some value which is displayed on the digital Gauss meter, which is negative in this case. So if you want to see that, okay, if I am taking it away, in that case what I would have, in that case what I will do, that it should be the 0 value in this case. Okay. So what I will do, that I will make it 0 if it is, even if it is not 0, so that I calibrate that my the magnetic field is completely zero when I am in a region which is away from the electromagnetic pieces in this case. Okay. So let's have a look at it. Now what I do that without putting on the stand, let me have a small experiment which I am looking at. Okay. Here what I have done, I put the this in the this probe into the electromagnetic pieces, and what I found is that my value is negative. Okay, so it is negative value which is displayed here. Okay, so this value can be corrected. For example, now if I flip this probe, then this will change to positive value. Okay, so now if you look at here, now I am getting the positive value. So how the magnetic field, what is the direction of the magnetic field when it penetrates your the probe, that will decide the sign of the magnetic field in this case. Okay, so if it is other way around, then we would have the negative sign. If it is on the other side, then it will be positive in this case. Okay, so now we have this value. Let me do it quickly. What we are trying to do here, here we have this, I am putting it here. Okay, so now, okay, let me have a look at it. Okay, so I will put it from the other side so that my displays can be seen easily. Okay. Okay, so I have done this one. So now if I would like to increase the value of, let's say that if I am increasing the value of the current which is passing through this solenoid coil, I am increasing the value in this case. Okay. So for example, if I keep on increasing this value, in that case what will happen? You would have increase in the value of the magnetic field which is generated during this process. Okay. So let's say that if I am putting it somewhere, we can calibrate it or we can do it again and again. Okay, so let's have this value fixed. Let's say that 1000 Gauss. Okay, 1000 Gauss. If I would do it like this, and if I toggle this button, in that case what it would give you the 99 Gauss multiplied with 10. So it will be 990 Gauss of the magnetic field which is being produced between the pieces of the electromagnet in this case. Okay, so that's one thing which we would like to have from here. Okay, so now our first task is complete, that we have fixed the value of the magnetic field in between the pole pieces of the electromagnet in this case. Now let's go to the second step here. So I would like to replace this probe. Okay, so I would like to replace this probe with the current carrying specimen, and let me put it back, and here I would have this the current carrying specimen which is there. Okay, now I have done this. Okay, so here let me have a look at the setup now. Okay, so we have I would like to switch it on the setup here, and we would like to see that what will be here. We have a few values. Okay, if you have a quick look at this setup here on this end. Okay, I hope that it is visible. So it is this value is like, let me have a quick look at it. Okay, okay, here we have this value. Okay, and now what I am going to do is that this is the value of the current. Okay, let's fix the value. Let's say if I put it like like some value. Let's say that if you are increasing this value, let's say that I have kept it about 1 milliamps, no? So what is the value of the current which is passing through this specimen, that we would like to put it like 1 milliamps, okay? Let's say that it is this value, okay? Now we have this value which is being displayed here. We have this 1.05 milliamps, and if I toggle this switch, in that case, if you toggle this switch, in that case what you would have, you have the value of the voltage which is which you are getting, and of course you are having the sign negative, okay? So let me point it out, okay? So we have the negative sign on the Hall voltage in this case, okay? So if you want to know that why it is negative, in that case let me do it once again, okay? If I put it other way around, okay, from here, let me flip the, okay, this specimen. Now my Hall voltage should be positive, okay? So let me do it other way around, okay? Okay, so we have this value. Now, if you want to increase the value of the current, I have increased it, and you will see that here you would have again the negative value, okay? So we would have this value of the Hall voltage, okay? Okay, and with the help of, now what we will do, that we would have this observation table, and this observation table we have to know that why this how we can have the information of the current and voltage characteristics of the Hall effect in this case, okay? So now what we would have here, okay, so we are just doing the calculations. If you look at the manual, then we have this manual, and here we would like to put the values of the thickness of the crystal, and then you have the current, and then you have the Hall voltage in this case, okay? With the help of this, all the information, we can have the information about the calculations which are there, okay? I hope that this will help you to understand what is happening with this system, okay? Let me have a quick look at it, okay? Okay, here you see that the value of the Hall voltage that has been changed from one point to the other, okay? So we have this positive value, okay? So that's the region, okay? What we can do, if we flip the the probe in this case, in that case you will get the required value of the Hall voltage in this case, okay? So why we were getting negative and positive values, that can be easily defined when you flip the crystal, number one. Plus second thing is that we have to take care at what would be the possible value of the Hall, this magnetic field when you are putting it in, okay? Okay, thank you.